So this talk is a technical side-by-side comparison between the two leading embedded Linux build systems, Buildroot and Yocto. If you know one of the two but not the other, then this talk is for you. You might have to switch from one to the other at some point for your next project. And so this talk is meant to help you in moving from one to the other, in translating between them. I'm Luca Ceresoli, and I live in Bergamo, northern Italy. I love Linux, I love embedded, I love open source. And in the past, I've been using Buildroot for several years as an embedded Linux engineer. And I've also become a modest contributor to the Buildroot project. Last year, I moved to AIM Sportline, where I'm developing the next generation cameras, data loggers, and dashboards for racing applications. And Yocto was being used there, so I started learning the new tool. And it was a big effort, because even though they have very similar goals in large part, they are completely different. And so it took a lot of time to understand how things that I was used to do in Buildroot should be done in Yocto. So here is the most relevant things that I've learned. Okay, first, this talk is not a tutorial, and it is not a comparison between the two to help you select the best tool for you. If you need one, there are a few out there. So there's a very nice talk and a couple blog articles. I suggest you look at them. They are pretty much unbiased, and I suggest them strongly. So the fact that they both end up with is basically both Buildroot and Yocto are very good tools. Each of them is better than the other in several relevant use cases. So chances are you'll use the other one for your next project. Since they both do build embedded Linux-based system, it is no surprise that they have something in common. So basically, each of them maintains a sort of dependency graph between several steps to build the whole project, which is a big task. This dependency graph with actions to get from one node to the other is pretty much all they have in common technically. For the rest, they are implemented based on completely different code bases, and they have very different approaches. Buildroot is based on two big pillars. The kconfig configuration engine, the one that's used for the kernel, for BusyBox and many other projects, to configure it and tell you what to do. And on make, the very widely used build system scheduler, to actually make the build. The approach with Yocto is very different, because it has only one tool that is pretty much specific for that goal. It's not really used for other things. And it doesn't have a configuration engine. It has BitBake, which is somewhat similar to Make, and does all the build scheduling and coordination. Another big difference in the two projects is the goal of Buildroot is basically generating a kernel, a bootloader, a root file system, a tool chain, and so on. While Yocto generates a distribution. So it generates actual packages, IPKG or DPKG or RPM, and you can really have a single board computer where you do IPKG install or similar to install packages with dependencies, just like any regular distribution. For most embedded devices, this is not really used, because for good reasons, people prefer to have a monolithic root file system and upgrade it completely, not by packages. Yocto can also produce kernel, bootloader, rootfs, and whatever, but it is a sort of byproduct of packages. So this is a major difference. Even if you don't care about packages, it is a major difference, because you have to understand what it does internally to make a good use of it. So you will have to think packages and not think building a root file system as in Buildroot. Okay, the topics that one could cover are many. So I just laid out a few of them, those which have, for which I have an experience with, and that exist in both Buildroot and Yocto, so I'm not talking very much about packages actually. So I'll cover bootstrapping your first project. The naming difference is how the two tools name the same thing in a different way. Where to put your own stuff in layers or external trees, writing recipes, how to command the build, understanding what's happening, customizing your root file system, and a more advanced section on recipes. However, I will not be able to cover all of them in this talk. So if you are specifically interested in one of them, just raise your hand and tell it. Otherwise, I will skip on some sections and focus on those that are more interesting. Okay, so if you need to start a project, it's quite simple with Buildroot because there is one repository. It's somewhat similar to the Linux kernel, so everything converts into one single repository, and you have to clone that or download that only, and you basically have everything in it. It's a sort of batteries included policy. With Yocto, it's a lot different. Yocto is structured in layers, so you are supposed to use a few layers and compose them to make up your own build system. And the first thing you should do is to clone the Pocky repository, which is already a collection of a few components, including the very basic rules needed for the basics of every embedded system, at least up to BusyBox. And on top of that, you probably want more layers with more ingredients. One is the meta open embedded layer, which is a collection of a long list of packages. If you need some executable or some library that you are used to use, then probably it's in meta open embedded. And so it's very likely that you need it. And you might want additional layers, such as SOC vendor layers or board vendor layers, and so on. So there are many, many layers out there, and there is luckily a layer index on that site where you can see a long list of existing layers. So you can go there and search for layers for your board or for like Qt5 or other important pieces of software that you need. All right, then next step is to configure your build system to tell it what you want to build and at least for which machine. Buildroot has a set of dev configs for well-known boards. Each of them, well, most of them are minimal booting configuration, so they boot a complete toolchain and everything up to BusyBox to have a booting board. So you can start from there for your project. And or if you want to start from scratch, either for learning or because there is really no board similar to yours in Buildroot, then you at least need to have a working kernel, a working bootloader, and know which kind of architecture your chip is. And so you enter the configuration menu of Buildroot and tell it which CPU you have, which variant, and where to download the kernel from, which dev config to use, which device tree, and the same for U-boot, and that's it. So it's basically just, you need the components. So this is how it looks for configuring the kernel. It's the familiar kconfig interface. In this case, we are configuring for a mainline kernel. Okay, for Yocto, the first step you need to do every time you want to use its tool, BitBake, you have to source a script called OE init-build-env. It will define some environment variables and create the first time the build subdirectory where you're supposed to work when you use Buildroot, when you use BitBake, sorry. And then if you want to start with a working configuration for your board, then look for that configuration in the conf/machine directory in your SOC vendor layer. There's probably one, and then define that machine name in the machine variable. The simple way is to add it to conf/local.conf file, machine equal the name of your machine, and then you can start the build. And starting the build with Buildroot is just a matter of calling make, because it uses the make build engine. By default, it will build all, which means everything up to kernel bootloader and root file system and images and so on. It's a little different with Yocto because to BitBake you need to pass at least one target. which for a bootstrap is probably core image minimal, which is an image with minimal software, pretty much like Buildroot, everything up to BusyBox and a little more. So they will start the build. Okay, as I said, the two tools are completely different even when they do the same thing, and they name the same thing in different ways. So what they have in common, as I said, is a dependency graph of actions to build every package. So a package is either an application or a library and so on. But for each package, they also have sub steps to like download, extract, configure, build, and so on. So there is a naming about this, and each of these of the top-level components is called packages in Buildroot and recipes in Yocto. It's pretty much the same thing. So it's the set of rules to build some piece of software. Okay. So for Buildroot, each package is also a make target. So you can just do make space libxml2 and it will build it. For Yocto, it's similar. You have to do bitbake space name of the package. So it's pretty much the same here. They will build all the dependencies of the package and then the package itself. To build a package for the host machine natively in Buildroot, you have a package with a host-prefix, like host-libxml2 to build it for the host. And in Yocto, it's called package name-native. It's the same thing here. Each of the steps needed to build a package that is called a task in Yocto. In Buildroot, there is no strong naming convention. It's just called task usually. And in Buildroot, these steps, they're called steps. In Buildroot, each step generates also another make target. So you have libxml2-configure-source-install and so on. And so you can run up to a specific step of each package. In Yocto, it's a bit different because it's a different namespace. So you have to call bitbake-c the step you want to stop to, and then the name of the packages. So it's slightly different in syntax, but in the end, it's quite similar. If you just specify the package name, such as make BusyBox in Buildroot, that means build everything needed to build that package. So each of the steps needed to build it. The equivalent in Yocto is called build. So bitbake-c build name of the package. If you omit the -c parameter, it's the default. All right. So the steps or tasks in the two systems are quite similar. So the names are different. So Yocto says fetch and Buildroot says source to download the sources. Unpack and extract is unzipping. Patch and configure likely have the same name for once. And then compile or build, it's the actual compilation of the package. Finally, there's a difference in the install step. There is only one in Yocto, and there are two in Buildroot, although they could be merged. They will probably be merged in a future version, but at the moment it's like this. So you can install target, which means install in the target root file system, or install staging, which means installing the staging directory for other packages to build on top of it. Okay, and then the deploy step in Yocto is called install images in Buildroot. So it means installing anything not in the root file system, but straight into the artifact output directory. Okay, so this is just a recap of what I said, along with the name of the files where all of this is defined in each build system. Okay, it's not possible to talk about Yocto without talking about layers. However, I will not cover this section in detail. I will skip most of it. Anyway, in Yocto, a layer, you have to define a list of layers, which is a list of directories. So the POKI and other directories. What it does basically is it generates a recipe whenever there is in a layer a file with a .bb extension. If on upper layers there is a file called bb_append, then it will be really appended to the first one. So in the end, what bitbake does is concatenate all of those files and then parse the concatenated output. So in your bb_append, you can modify whatever has been defined in the lower layer. So it's a pretty powerful mechanism to extend a recipe. Okay. Both in Yocto and in Buildroot, you're supposed to generate a real product, and so you probably need some customization. In Yocto, you typically have a top-level layer with your own customization, your private packages, your machine definitions, and so on. And also bb_appends to modify lower-level rules if you need. With Buildroot, there is a tool that is called br2external, out of the name of the variable to implement it, which is similar to Yocto layers, but simpler. And it is meant to add things to the Buildroot code base without modifying it. But it's not as powerful as Yocto. You cannot really modify existing recipes. You can add packages, kconfig options, devconfigs, boards, patches, and so on, but not modify lower layer packages. So if you find a bug or a missing feature in a Buildroot recipe, the recommended thing is you do it in Buildroot and send your patch upstream, and keep in your own layer, your external directory, only what is really specific to your private packages and private code. Okay. So also, even writing recipes is something that I will mostly skip, but because it is well documented in both build systems, I just would like you to have a glance at the differences. This is how a directory for a package definition looks like in the two build systems. So in Buildroot, under the top-level directory, there's a package directory with a subdirectory for each package, which contains config.in for kconfig menu, for your package to appear in the menu, a .mk file with the actual rules for building, and a hash file with hashes to check for package integrity. And then you can have patch files and maybe additional support files. In Yocto, you also have, well, you can have multiple layers, but under each layer you have one or more recipes dash something directory with some subdirectories. And each subdirectory can contain one or more recipe. Each has a bb extension or bb_append. And so the bb is equivalent of the mk plus hash file, which are all in a single file. There is no equivalent of config.in because there is no config interface. And patches are put in a subdirectory, which can have any name. If you use files, then it's one of the defaults, but you could use a different name. A recipe looks both different and similar in the two build system. The syntax is completely different. This is a Yocto recipe. This is a Buildroot recipe. Buildroot is a bit more verbose, and but the structure overall is the same. For a very, very basic recipe, you have to tell it where to download the software, what it depends on, how to configure it, build it, install it, and that's it. So the structure is really similar. Only the syntax is different. In Buildroot, you also need a config.in file for your package to appear in kconfig. That's it. Okay, and well, for well-known build systems like AutoTools, CMake, and many others, both Yocto and Buildroot have some base code to simplify your rules creation. So in Yocto, you do just inherit from a class, like inherit AutoTools. In Buildroot, you do use this eval AutoTools package syntax, but it's the same, so you basically can skip writing any kind of code in most cases. All right. Finally, when you write in a rule, you have a set of variables predefined by the build system. This is only a small subset just to show how they differ in how they're looking. And the main difference is in Buildroot, each variable has the name of the package as a prefix. This does not happen in bitbake. And that's because in bitbake, each recipe is evaluated in its own namespace, while in Buildroot, all the recipes are basically they create a sort of huge make file, so there is only one namespace, and so you need a prefix for each recipe. For the rest, they are quite similar. They provide the paths and options and so on. Okay, command in a build is not only a matter of running make or bitbake or image minimal. You may want to command a more specific build because you are developing a package, for example, and so you want to troubleshoot that, or you want to run a partial build. So you can do it in both build systems. It's actually fairly similar, except for the syntax. In bitbake, you have the -c option, which in Buildroot becomes dash name of the step. So for the rest, it's pretty much the same. You can build everything until a package, or rebuild the package and whatever follows, and so on. You can clean everything. So nothing really, super interesting here. Okay. In Buildroot, does not build in parallel each step. It builds steps serially. Parallel build is experimental, but it typically works sequentially. But you can build in different directories, in different subdirectories, just like you can do with the kernel. Just pass it O equals name of a directory. It will create a subdirectory and work in there. So you can, from the same sources, have different builds with different configuration. You modify the sources and rebuild everything. So it's very handy. And in this case, you can like enter the other directory and run the other build in parallel. So multiple builds can build in parallel. With bitbake, it is completely different. It cannot run multiple instances at a time, but it's mostly unneeded because it reuses very effectively the build artifacts. So when, for example, you build your core image minimal, after the build, you have many packages that have been built, and then you want to build another image, which contains much more software. My image huge. In that case, all of the packages that are common to the core image minimal will be recycled. They will not be rebuilt. So it will save build time when you have to build multiple configurations from for the same machine. But not only. If you want to build for another machine, you can just change the machine variable and then build the same or another image. And if the other machine has the same architecture, it will not need to rebuild most of the packages. Like it will rebuild probably the kernel, bootloader, and a few more that are machine specific, but for the rest it will recycle everything. Okay, so as I said, these tools have a dependency graph, so they have to keep track of dependencies. This is one of the core features of the make program. However, how it does it is not enough for the complex need of an embedded Linux build system. And so Buildroot has its own mechanism to keep track of dependencies, which is it creates a timestamp file at the end of each step to know where to restart from. And this is an empty file whose date is relevant, of course. And it tracks successful completion of the task, but it doesn't keep track of what it has done and out of which rules. So if you change the rules, if you change the .mk file, for example, or the options, it doesn't know it has to rebuild it, if it has to rebuild it. So you need to do it to know it. If you are building an embedded Linux system, especially if it's a small system, you probably know what you need to rebuild because you need which packages you have into. And so typically you need to rebuild when you either change the configuration related to a package, like enabling some more feature in the same package, or because you are developing a package, you are modifying the .mk file yourself, and so you want to rebuild the package, of course, with the new rules. In this case, you can trigger a rebuild in different granularities. The coarse granularity is just make clean, and make is the safest option. Remove everything, rebuild everything. It could take time, but if you're not really sure what you have to rebuild, it's safe. If you need what you want to rebuild, like I modified the rules for this specific package, you can just do make, name of the package, dir clean, name of the package. This dir clean will remove the build directory for that package, and then it will rebuild everything for that package. So it you will save a lot of time. Or you could even just run name of the package reconfigure or rebuild. This will run only the configure step or build step and every step that follows. So it's very useful if you are developing the recipe for a package. All right. So Yocto has a more complex and powerful mechanism. For each task, it maintains a hash file. So for each recipe, it maintains a task file. So whenever you change anything in the recipe, it knows because it hashes it. So if you modify the recipe, modify the compilation rules, for example, and then run it again, it sees the hashes different and it knows it has to rebuild. So in this case, you don't have to think about what to rebuild. On the other hand, it might rebuild a little more than you need, but also rebuilding is quite effective if you delete the temporary directory because it has a state cache of everything it has built. So if you rebuild something from the same rules, it will just copy the old files without rebuilding everything. Okay, the first time I've made my Yocto build, I started wondering where are my output files, which is not so easy because the directory structure is a lot more complex than Buildroot. In Buildroot, from the top level directory, there is an output directory, which has a build subdirectory, and in it you can find one subdirectory for each package. So like output/build/bgbox-version number. In Yocto, from the top level directory, you work inside the build directory, which has a TMP subdirectory, work subdirectory, a tuple describing your machine directory, and then the package name, and then the package version. So it's very deep. In that, you have many subdirectories because it uses several steps to build it. So typically, in one, you have the source code, in one, the build artifacts, if out of source build is possible. In one, you have everything that gets installed by the package, and then the packages that get generated. Also, root file system in generation is following a similar rule. So in Buildroot, from the top directory, you have output/target/your root file system that is being progressively generated. In Yocto, it's very different. It doesn't generate a root file system while building. At the end, it does it in build/tmp/work/machine tuple/the name of your image/the version /rootfs. So it's very deep again, but there you find pretty much the same result, but it's built only at the end because an image recipe is pretty much like every other recipe. So when it gets built, what Bitbake does, it creates the rootfs as an empty directory and then installs all the packages into it. Okay, and well, the output directory is the one that you're really supposed to use as a user, and in this case, Buildroot has output/images, and there you find your build artifacts like kernel image, build device tree files, and so on, and of course your root file system image. In Yocto, you have build/tmp/deploy/images/the name of your machine, and then you have pretty much the same result. So, well, the tab key is your friend in Yocto much more than in any other software that I've known. But I hope this table will help you in making your way through its directories. Okay, build systems are not really simple toys. They do a complex task, and so it's very important that you understand what's happening because things will break at some point, and you need to find your way out of this. So first, you probably want to understand what it is going to build and why it is building this weird package that you don't want. In Buildroot, there is a very powerful tool, which is graph_depends. You just run make graph_depends, and it will produce a PDF file with this graph, where I hope you can see there is a dim gray and a darker gray. Dim gray is for host packages, and dark gray is for packages that go on the target. So you can clearly see who depends on what and why you are building host-get image, which you don't know what is. If you want to focus on a specific package, you can ask it to generate a graph excluding all the host packages, because maybe you want to know only what goes on the target. You have plenty of room on your hard drive, and you want to do the graph depends only for a specific package. So in this case, you can see what Apache depends on, and in a very focused way. For example, to understand, okay, I want to put Apache, what kind of dependencies will it bring in? So it's very visual and easy to understand. I didn't find any similar tool in Yocto. I don't think there is one. Actually, it can generate this kind of graphs, but that is quite unusable because it's just too huge. And there is a tool that is somewhat similar called Task Explorer. It doesn't show a graph, but it shows for each task the dependencies and reverse dependencies. So the information it shows is very, very granular. It's not at the package level or recipe level, it's at the task level. Still, it can be useful in some cases. Okay, so when you run the build, they do a lot of things, so you might want to understand what they're doing, and more important, what goes wrong. Buildroot is very verbose by default. It tells you, I'm starting this step, and then all of the output for that step, which can be very, very verbose for compilation or auto tools configuration, for example. This is nice when there is a build failure, because it's typically on the last few lines on your terminal, so it's immediately there. It also has a concise output where everything else is saved into a log file. While Yocto has a different approach, by default, it doesn't show a log-like output, but only what is happening at the moment. So if you go take a coffee and get back, you don't know what happened in the meanwhile. You only see what is happening at the moment in a quite animated way. And if you want a log-like output, maybe for a build system that is unattended, you can just pipe into cat, and so in this way you will have a log-like output where it says, I'm starting this task and I finish this task. So it's a simple trick to do that. But if you want to understand what went wrong, the best way I suggest is to look at the logs. So for each task, it saves a log in tmp/work/tuple recipe version/temp, and there are log files, one for each step. And log files are collected and never deleted because they have like the PID number appended. So you can look at the logs for each build, and you will. This is the first place I typically look into when a build fails, because this is where detailed output is found. Okay, and finally, if still you don't understand why things go wrong, you might need to enter its brain and understand what it's thinking. So you thought you tell it to do something, it's doing something else. So the first thing you should do is look at the variables. Maybe you didn't set the variable correctly, maybe there's a typo. With make-s print vars in Buildroot, you can have it print all of the internal variables, and you can also filter them. One nice filter is the package name as a prefix, so just like print all the variables for the BusyBox package. And in this case, it gets easy to debug package. You can also print unexpanded variables. And if that's not enough, you can print the whole make database. So this is a make feature, make-qp. It will print a huge output with all of the rules, all of the variables, which is a sort of last resort to debug. Bitbake has a somewhat similar option to print vars, which is based on the -e option. Bitbake-e will print all of the global environment, so all of the variables that are not recipe specific. If you also add the recipe name, it will print only variables and functions that are specific to a recipe. So there is no global variable space. There is one variable space per recipe. This is also a useful tool because it tells you in which file or in which files each variable was set and modified. So it's very useful to debug if you have multiple layers touching the same recipe. All right, so just briefly on this this section about customizations. So if you are building products, you most likely most likely the standard build system is not enough for you because you want to customize your system with your own product-specific stuff. And so in Buildroot, there is basically at the top level, there is your kconfig configuration where you tell it which packages you want and many other options. And so you can use it with the known menu config interface. And after that, you have a single file which describes whatever you want. In Yocto, there is no single file for your configuration. Typically, your configuration is your top-level layer, so you have there all of your stuff, and you probably will have a configuration file for each machine, basically each product, and you probably also have recipes and whatever, but what's more important is you probably have image recipes. So a recipe for your image where you tell it what packages you want in. So the same thing that in Buildroot is in a single file, in Yocto is scattered in several places. So you have to organize your files in a way that suits your needs. Okay, adding a package in Buildroot is quite simple. You enter menu config and enable it. That's it. In Yocto, you have to first find if you already have the package in your own layers. There is a command called bitbake layers show recipes to list them all. And also, if it's not there, you can go on the layer index, which is also a recipe index, so you can find layers with that recipe. And it's very comprehensive also. And then you can create an image listing the packages you want in it. Okay. Finally, Buildroot has a nice menu under Make Menu Config, which is called System Customizations. So where you can define like the init system, the dev management system, if you want locales or not, and many other options affecting the whole system. So it's very handy because many things that you will need are there in a menu, and they are easy to find. But the same is does not happen with Yocto, where the same things are scattered in different recipes in different places. So this is just a correspondence table of a few of them, but there are many more. And basically, oh, sorry, where is it? What I typically do is first I look in the first I look into the Yocto reference manual, which is quite comprehensive, and look there for the option I need. If I don't find that, I grab into the Pocky source code for a relevant word, and then I see if some recipe implements what I need. Okay, I think we are pretty much game over, right? So I hope this was helpful, and basically I showed you many things are very similar in the two tools but are named differently. Something is completely different and you will have to spend some more time on that. But there's nothing really impossible in changing from one tool to the other. And so I hope we have time for maybe one or two questions.
Just one, really,
okay.
A little shorter. You have any?
Which tool do you think creates a rootfs, a smaller rootfs, and if there are tweaks you can apply to achieve the smaller possible rootfs?
Okay. Which tool is helpful to generate the smallest rootfs? Well, actually, Buildroot by nature and by design is meant to be as minimal as possible. Which means not only being simple to understand, but also it tries to generate the smallest possible root file system. So by default, it enables the minimal set of options. So the generated image is typically very small. It also implements all of the alternative libraries that help to reduce size. With Yocto, it is meant to be a more complex and complete system, so it is a little bit larger if by default what it produces. There are, however, additional layers that instead of adding stuff, they help in tuning the size, like adding alternative libc, which are smaller, and so on. So you have to work a little bit more with Yocto. You have to find like the Pocky Tiny, I think it's called. So it's an alternative version of Pocky, which is smaller. So you have a little bit more work if you need to really fine-tune your space size equation. Okay, thank you very much.
Okay, thank you.